To create deeply surreal, custom landscapes, we have to stop relying on the generic defaults of standard AI models. If you want specific, repeatable aesthetics, you need to train a dedicated video model, known as a LoRa. This file learns the exact mathematical structure of your style. Standard text prompts guess at what you mean, often producing flat results. A custom-trained model forces the output to match your wildly intricate vision. Before building one, check your setup. You will need a graphics card with at least 12 gigabytes of VRAM, 15 source images, and the base open-source framework installed. The neural math running underneath this process is complex, but your actual workflow requires no coding. Today, you are just dropping files into folders and letting the algorithm calculate the rest. Step 1 is building the dataset. Start by gathering 15 to 20 high-quality images that clearly represent the surreal aesthetic you want the model to learn, and put them in a single workspace folder. These images cannot be mixed sizes. For the algorithm to accurately process the visual data, every single file must be cropped to exactly 1024 by 576 pixels. They also need to be identically named in sequence, like image 1, image 2, and so on. This uniform structure allows the model builder to parse your dataset without throwing errors. Make sure these source images have varied compositions. If they all look like flat textures, your final AI video will just pan across a static photograph instead of generating actual motion. This perfectly cropped, strictly organized folder is your mathematical scaffolding. If the data is sloppy, the entire training sequence will fail before the first calculation. Now upload your organized folder into the model builder environment. Once it loads, navigate down to the training parameters section. Find the learning rate and set it to 1e to the fourth. This slow pace prevents the AI from ignoring the fine details of your images. Next, leave the batch size strictly at 1. Raising the batch size will max out your VRAM and instantly crash your system. Finally, type 1500 into max steps. This is exactly how many times the model analyzes your dataset. Push that number too high and the model will overfit. It becomes so obsessed with your source images that the final video output turns into a corrupted, noisy mess. These three metrics, learning rate, batch size, and max steps, create the exact conditions required to successfully translate your art into a functioning algorithm. With the parameters locked, hit Start Training. The interface switches over to a live progress monitor. This is the loss graph. During processing, this diagnostic tool tracks the performance of your model. You want to see this line steadily moving down. A decreasing value proves the AI is correcting mistakes and mapping your style. Once the 1500 steps are finished, open your output directory. You are looking for a newly generated file with a .safetensors extension. That single file contains the complete mathematical representation of your visual dataset, permanently saved to your hard drive. Switch over to your video generation interface. Select the base model, and then load your new safetensors file directly on top of it. Now, type out your prompt. For example, a glowing geometric desert with floating crystal oceans. Hit Generate. The base model understands the concepts of a desert and an ocean, but your custom file overrides its default aesthetic, forcing it to apply your specific style. Watch closely as the complex algorithm processes the individual frames, eventually rendering them into a completely fluid, moving reality. If you compare the shapes and colors in this video back to your original folder, you can measure exactly how the final output inherited its specific traits from your 15 starting images. You just successfully engineered a custom AI model from scratch. You built a specialized neural network trained entirely on your own terms. Look at the detail in the geometry and the consistency of the lighting. Because that safetensors file lives locally on your machine, you now have the permanent ability to generate infinite variations of this specific dreamscape without relying on an external service. Your next step is to clear out that dataset folder and try the process again with a completely different medium. Use physical claymation photos, or scan in a series of watercolor paintings. In our next video, we will take this exact rendering and build a custom generative soundscape to match its atmosphere.